Hello and welcome to the Chapter 12 lecture part 1. For this lecture, we're going to be focusing on nutrition, food security, and agriculture. So we need to get out some definitions out of the way first. So here they are. Macronutrients, also known as macros. If you've ever, I've tried a diet where they're like, you got to focus on your macros. Those are carbohydrates, proteins, and fats. Your micronutrients are vitamins and minerals. And if you look at the little picture on the bottom, water is also a really important component to being healthy. And there's two other definitions when you're looking at lack of nutrition. One is chronic undernutrition, where you're not actually getting enough calories. And the other one is chronic malnutrition, where you have a deficiency in key nutrients, like some minerals, vitamins, or minerals. So while globally nutrition is improving, still about 1 in 9 people suffer from chronic undernutrition. So what are some of the effects of that? These are just some examples. If you're deficient in vitamin A, you can see all the different things that vitamin A does. If you're deficient in iodine, it can impact your thyroid function. And just the little infographic down in the lower right just shows that the cumulative effects of malnutrition can affect a child's ability to learn and just to develop properly. So here's a map of food security around the globe. And again, there's a few notes at the bottom about what chronic hunger and undernutrition can do. Most of those, the countries are the developing countries where you're going to find this the most prevalent. And what are some of the other things it can do? It can cause mental retardation, stunted growth, death from infectious diseases such as measles and diarrhea, because if you're not getting adequate nutrition, you're leaving yourself more vulnerable to getting sick. And if you notice, the United States there is in green, meaning that we have the highest score for food security, but we actually have a lot of food insecure people in the country. And this is a map, this is pre-pandemic map, and that food security is on the rise. I believe this is from 2014, the data here. And by percentage of population, the upper graph shows overall rates for the entire population. The lower graph, sadly, is rates among children, and it's higher among children than for adults. It says, but by the number, cities have the most people with food insecurity. About 27% of food insecure people are ineligible for food stamps. And I'm not sure, I don't think those rules have changed since I made this slide. And then things like, high unemployment, cuts in food stamps that we've had have all made food insecurity increase. And so it begs the question also, what about right now when we're in the middle of a pandemic, we have so many people unemployed? So I did a little bit of research and I found these two graphics. Globally, we're looking at basically doubling the number of food insecure people due to the pandemic. In the United States, if you look at the numbers and you compare it to the previous graph, we have just a whole lot more food insecurity going on in this country because of the economic consequences of the coronavirus pandemic. So moving along to what are the threats to food security? One is population growth. As the world gets more and more people, we have to find ways to feed all of those people. Another one is widespread malnutrition. So if you feed people, but they're not getting the right vitamins and minerals, and so if you eat say a mostly carbohydrate-based diet, say a lot of rice or a lot of grain, but you're not getting the other two macros in there to get those vitamins and minerals, you can then suffer from malnutrition. And then the third one that I don't think we often pay enough attention to is food loss and waste. So in developing countries, most of that occurs during production and transportation, but in developed countries like our own, a lot of it happens at the consumption stage. So if you look at that statistic there, about 1/3 of the food produced for human consumption worldwide is lost or wasted. So this was from the 2016 year of pulses when they were really trying to bring a lot of attention to these things. This graphic also kind of shows what are the different components of food security. And you have availability, which includes things like production, processing. How do you stockpile it? Access, can people, so you produce the food, but can people access it? So that's going to include things like transportation, affordability, marketing, equitable distribution of that food. And I put preference in there too, because people have to be willing to eat the food that you also provide. And then utilization, what are the global health indicators? Nutritious food, food safety and quality, and then clean water and sanitation so that food doesn't spoil. So going back to that food waste idea, Again, that 1/3 statistic's pretty high. And what does that mean exactly? That would be enough food to feed 3 billion people. And in a world where we have almost, like close to 1 billion people going hungry. And in this country, we waste almost 50% of the salad food. And I'm laughing because I'm kind of guilty of all of this. I find stuff in my fridge and I'm like, oh, that's got to go. 50% of all of our salads, and it's because salad stuff doesn't keep for very long. 1/4 of all of our fruits and vegetables, about 20% of our breads and bakery items, and about 10% of our meat and fish. And so it's kind of a sad statistic. So what are the impacts then? So this is how much money the average family wastes each month due to food waste. Wasted food were a country, would be the 3rd largest emitter of greenhouse gases. Producing food actually is a pretty big greenhouse gas producer. And then just 2.5 billion acres to produce the food that we end up wasting somehow. And a whole lot of fresh water goes into producing our food too. So finally, the methane, going back to the climate change thing, methane is a big greenhouse gas. And so while we can put our food waste into our compost bin, our yard waste bin in this area, in a lot of parts of the country, all food waste just goes straight into the garbage, and which then goes to a landfill. Okay, so on the other end of the spectrum, we have overnutrition, which means you're taking in more food energy, more calories than what you can use, and so it leads to being overweight. So about 1 out of 3 Americans is obese. You can see the graphic down here as far as rates of obesity for kind of some sample countries, the United States being the one on the far right. 1 in 3 children, I don't know if I believe this statistic, it seems pretty dire, but they're predicted if we keep going I think it means if we keep going at the rate we're going with if you look at the increase in obesity for Americans over time, this is where we're headed if we don't turn that around. Why do we have such high numbers? There's actually a really high correlation between poverty and obesity. The upper picture, it's a little hard to read, but it is, this is median income, and the red being the lower income, and then this one down here are rates of obesity. And you can see there's a pretty good correlation between low income and high rates of obesity. And part of that is that fast food, which is nutritionally deficient but highly caloric, is often more available and cheaper than, say, buying healthy fruits and vegetables. So, but 83% of countries worldwide have an obesity rate greater than 25%. So the Green Revolution, and again, this is different than like the Green New Deal. The Green Revolution, starting in the 1950s, was actually increasing our ability to produce more food. How did we do that? By selectively breeding crops, also known as artificial selection for higher yields. We started using more fertilizers, industrial farming like mechanization and improved irrigation, using pesticides, and using GMOs. And we're going to be looking at each one of those. So for selectively breeding crops, this is interesting. This is yields for corn in the United States. And this is not total corn produced. This is grain yield in bushels per acre. So what that shows is that for each acre, starting at about the 1940s when the Green Revolution started, our ability to produce more corn per acre has gone up pretty drastically. And then arable land. If you look at how much land we're using across the world, again, if you look at the years, we have increased more recently the amount of land we're using for producing food. And just wanted to, you see that little symbol a lot, the HA, that stands for hectare, and it's about 2.5 acres. Okay, so arable land is another term you see a lot. And arable land means it's land capable of growing crops. And if you look at world population, arable land and permanent crops, there's a little bit of a conflict between arable land and where people are going to live. So as population goes up, we're going to need more land to produce more crops. But as population goes up, we also tend to develop those areas where we once raised crops. And so if you look at any area that's undergone a lot of growth, places, in fact, my house is on what used to be pasture land, according to a man down the street when I first moved in. I live in West Seattle. And so over time, my house was built in the 50s. Before it was built, it was just fields. And so that's pretty common as you have urbanization and growth, that you're going to lose some of that arable land to basically house your population. So But on the good side, the arable land that we need to grow crops has gone down over time because of the green revolution and all the things we're doing. Okay, so share of land used for arable agriculture, you can kind of see we're in the middle of the spectrum there for amount of land we're using for arable agriculture. This is as of 2015. And then projections. If you notice, we're kind of topping out though. The availability of arable land, it doesn't look like we're going to be able to increase it projecting into the future. Okay, so industrialized agriculture, this is also called high input agriculture. You're going to use heavy equipment. And part of that means downsides. You're going to use fossil fuels, fertilizers, pesticides, and a lot of water. So the upsides are you can get a high yield per unit area of land. And then the other thing that often ends up happening is you plant monocultures. If you're going to be using machines to do all your harvesting and whatnot, you pretty much need to have everything look the same in order for the machines to be able to do that. So the problem with that is that you might lack genetic diversity then. Okay, so here's just an example. This is not, I think we grabbed this slide from somewhere on the web, but just what can happen if you don't have enough genetic diversity is that if there's something happens to the one crop you have, like a pest, and this just is an example with bananas, then you might lose your whole crop. And if you don't have that genetic diversity, you may not have other types to turn to. So basically the bananas you guys eat are not the same bananas your grandparents ate. They are now produced by using clones of bananas. And again, if there's a disease or a pest or something that strikes, our crop supply can be in trouble. Okay, and then the other thing is that if you have these monocultures, pests, it's called coevolution, they might evolve specialist pests that might evolve to really make use of those monocultures too. So that can be an issue. And just another kind of a subtype of industrialized crop production is called plantation agriculture, mostly thought of as being done in your tropical countries. So your crops, bananas, soybeans, sugarcane is a big one, coffee, palm oil is another big one. Often they're gonna do a slash and burn or clear cutting type situation to get those plantation agriculture going. And you saw some of that in the biodiversity unit. Traditional agriculture is mostly using human labor, not mechanization to grow your crops. And so the food is mostly produced by the farmers themselves or mostly used by the farmers themselves. Often they have polycultures. So the opposite of a monoculture would be a polyculture. So a diversity of crops, reducing loss from pests and bad weather. And 42% of the world in developing countries practice this type of agriculture, and it produces about 1/5 of the world's food crops. So statistically, what does that look like? This little pie chart. So this is below 10 hectares. There's that term again. Remember, a hectare is about 2.5 acres. Looks like over 3/4 in Asia, 85% in Asia, versus large scale farming, so over 10 hectares, a little bit more evenly split. But again, look at we would be in that category. So in the US, speaking of the US, we do a lot of selective breeding, a lot of genetic engineering of our crops. We can produce more food on less land, and that means the cost is going to be less to the consumer. However, that doesn't include things like subsidies, pollution, environmental degradation, health costs, et cetera. So we so our agriculture industry generates about 1/5 of our GNP. And this is just a little graphic of the farm subsidies over time. And then this is just looking at since the early green revolution days, how much our grain production has increased in our country. I have some cool pictures. So if you want to see what industrial farming looks like, these are cranberry fields. This is how they get the cranberries. So they pick the cranberries, load them into a truck, and then they empty those cranberries by lifting the whole truck off the ground. This is a carrot factory, salad in the fields, and then wheat. And this is as you can see, highly mechanized. So food distribution, if you look at surpluses and deficits, we're on the surplus side over here. You can see the countries, Middle East and Africa, Asia on the deficit side. So, and the different bars are for different years, with the most recent year, 2010. And then, so Africa does a lot of food importing, and it's a lot of money for them. So one of the big pushes that I've seen for aid organizations is to see how can we get Africa to produce more of their own food rather than having to import the food. Not only is it expensive, but a lot of food gets wasted in transport, losses due to transport, food spoilage, et cetera. So this is food distribution. So exports, you can see that again, the North America, we're a high export country, and you can see the other countries that are too. What does that look like when we send it other places? When you see big ships like that, a lot of those ships might be full of, or sorry, a lot of those cargo containers might be full of grain. And if you look at the graph of food, this is exports per capita and imports per capita. The big exporters are actually, you know, Canada and Australia. The US is a net exporter, but not, sorry about that, not a huge amount, because let me just turn that off so that doesn't happen again. And go to alarm and off. We're not a huge exporter, partly because we also import a lot of food. So this graph up here shows imports versus exports over time. And you can see we do export more than we import, but the difference is not super huge, which is why we land more close to the line of equal rather than net exporters of food. All right, so GMOs, also known as transgenic organisms. I've never actually heard that used, but then I'm not an agriculture person, or bioengineered species. I have heard that one. So it's when you insert genes from another species to produce desirable traits. It's basically, you know, manipulating the crops at a gene level to get the qualities that you want. So what are the kinds of things that you are going to want? You want it to be resistant to heat, cold, pesticides, herbicides, parasites, you know, insects, disease, drought, salty or acidic oil. You want your crops to be able to grow well under all conditions. That would be your ideal crop. So what are some examples? So the golden rice, they put beta carotene in it to up that vitamin A. And we have a lot of examples of GMOs in this country. So one of the biggest examples is glyphosate resistant crops. Glyphosate, GMO crops have been made by Monsanto to be resistant to glyphosate, which is an herbicide. So it's like 80% of our GMO crops in this country. So what are the pros? Glyphosate seems, it's been tested and it seems to be safe for animals and insects. There's some dispute over that. It stays in the soil, doesn't leach into nearby aquatic systems, which is good. Degrades into harmless substances in just weeks. So that would be like a short residence time in the soil itself. So it's not going to build up or biomagnify. And then you can spray it right on. You don't need to plow it in or anything like that, which is going to which is not going to cause the soil to erode. All right, so what are the cons of glyphosate? Again, a coevolution. Weeds have been becoming resistant to glyphosate over time. So they've been able to develop a resistance to it. They dominate the market, so there's not going to be a whole lot of diversity. It's pretty much you need to use these GMO crops if you want your farm to survive. Possible loss in productivity and large cost to seed and companies and farmers. If you're forced to buy your seed from Monsanto and so that it's glyphosate resistant, they kind of have a monopoly on the system, and there's been some lawsuits over that. Could force the use of more toxic herbicides as those glyphosate resistant weed species go up. That's what the graph down here is showing over time. And there's a current lawsuit over dicamba, which is another herbicide produced by Monsanto, and it's they call it the dicamba drift. It's actually an herbicide that when you spray it on, it drifts easily into other farms. And so people who don't want to use those herbicides they're kind of stuck because of neighboring farmers using it, then it can drift onto your crops too. So this is just a trend in pesticide use in the US. And if you look at it, most of those categories have stayed fairly static. Some have even decreased, but the herbicides, this is 1964, have really increased over time. And a lot of that is the glyphosate. The common name is Roundup. All right, and again, I put the example of coevolution on this slide. This is, I'm not even gonna try to pronounce all of those, but there are just a lot of these super weeds are like developing that are resistant to these herbicides now. So advantages. Higher yields due to potential for improved characteristics, improved quality of the crop due to new, less spoilage, et cetera. Disadvantages, we don't know all the ecological effects. We never do. Some people feel that all this glyphosate put on the food is actually causing allergies. And then the increase in that pesticide, resistant insects, et cetera, herbicide resistant weeds. And then you can harm beneficial insects and then lower genetic diversity. So this picture in the middle, if you're wondering which foods are the most GMO, like highest amount of GMOs out there, you can look at the picture there. Okay, so also the other interesting thing, if you look globally, and this doesn't list all countries, but it's a good sampling, we are the GMO, we use more GMO crops than anywhere else in the world. The other place where you see quite a few is in South America, but nobody's like us as far as the percentage of crops that we use, hectares, the amount of hectares that we plant for these GMO crops. Okay, so pest management, moving on to the insect side of things. There are pesticides is actually any chemical that can control pests. So there's insecticides, which is what we're going to talk about next. Herbicides, we've already talked about, fungicides, and then rodenticides, things like rat poison, etc. And so we're going to move on to the pesticide part. So first generation was using natural chemicals, especially from other plants, to keep your pests away. Second generation are the chemicals. So it started with DDT in 1939. And DDT is something called a broad spectrum agent, which means you put it on and it's effective against a very wide range of pests. But the problem is that, you know, pests are insects and so are beneficial species like bees. So the chlorinated hydrocarbons is what DDT was, also dieldrin, which we still use. They're persistent and they can biomagnify. And then there's the organophosphates, malathion and parathion. They're not persistent and do not biomagnify, but they are highly toxic. So then more recently, we would develop narrow spectrum agents, which are toxic to a more selective group. So if you can target your insect rather than have it be detrimental to all insects, that would be good for insects like bees. So DDT was made famous by Rachel Carson. It was a highly used pesticide. They used to sell it in people's homes. They used to spray it on airplanes. We'll see a little video in class on this. And it was finally banned in 1972. And the person who had the most to do with that was Rachel Carson. She wrote the book Silent Spring. And what they found is that DDT biomagnifies through the food chain. So she wrote that book and to bring public awareness to it. So what was DDT doing to not just insects, but for birds? Most famously, they think it really caused the decline of eagles, peregrine falcons, etc. It was thinning their eggs, it was biomagnifying, and it was over time toxic to these animals. Since we banned it in 1972, this is the eagle population. So you can see the decrease in the chemicals kind of correlates to an increase with the eagle population. So DDT we no longer use, but dieldrin we still do. So the pesticide treadmill. When you think about a treadmill, look at this graph. This is kind of classic exponential growth. So pesticides, the unintended consequences, they may also kill beneficial insects, again, like bees. Pests may develop resistance to the level of pesticide applied. And then, so if that's happening, if you need, if over time your pests are developing resistance to this, again, that coevolution idea, what are farmers going to do? They're going to start using more pesticide to kill more insects. Okay, so we have a positive feedback loop going. If the more insecticide you use causes more insects to become resistant, so then you have to use more pesticide to kill more insects, and then you get more resistance. Classic positive feedback loop. All right, so then here's a little graphic on the bees, and I mentioned them a few times, but the situation with the bee decline in the United States and actually globally is a little bit more, is fairly complicated. They think there might be several effects, but pesticides certainly don't help. So, we think that the use of pesticides, widespread use of pesticides, is one of the reasons why bees have declined globally. So this is, and if you look, we're kind of middle of the road too for pesticide use as of per hectare as of 2017. Look at China, however, and I think I have another graphic for this one coming up for how much different countries use. So the problem is that, again, you get that pesticide treadmill thing, and we've increased our pesticides hugely since, since what was it, 1942, since basically the Green Revolution started. However, our losses due to insects have doubled since 1942. And then the environmental and social costs, have just, these numbers are hard to estimate, but I was looking for a good graphic for this and had a hard time. You can see pesticides is in the front, but being a farmer can be a hard life. Look at all the other things that can affect your crop. This is percent total loss, droughts, floods, heat, cold, it's just, can be difficult. There's a lot of things that can cause your crops to fail. So again, for conventional chemical pesticides, and the advantages is that they save lives, like the decrease in malaria, increase our food supply. Disadvantages, they can kill natural pest enemies, and they can kill beneficial insects like bees. You can harm wildlife and people, like the DDT ended up hurting the eagles. you can promote that genetic resistance, and then expensive. Farmers have to buy these and apply them to their crops. So we have started regulating pesticides, and whenever you think like environmental regulation, the era was the 1970s. And so we passed FIFRA, the Federal Insecticide and Fungicide Regulation Act, overseen by various agencies. And then the Food Quality Protection Act a little bit more recently. And the idea of pesticide residues. And so they always urge you to wash all your fruits and vegetables because unless you're buying strictly organic, you're going to have some of those residues on your food. But this one reduced the levels of them at the time and required labels. So if you are going to have pesticides used on your food, that you will know that. So what do we do? What are some alternatives? You can rotate your crops so you can keep those specialist species down. There's biological controls, provide homes for pest enemies, such as like that wasp, like totally eating that, caterpillar. Polycultures, plant diversity, so that you're, again, keeping those the specialist pests away. GMOs with genetic resistance, you can lure pests into sticky pheromone traps. Hormones to disrupt the pest life cycle, although you gotta be careful of unintended consequences for that one. This is just a picture of the intercropping, just kind of planting different species and plant them together. And again, it can keep those specialist pests down. It can also actually really be useful to your soil because any one crop can deplete your soil of certain nutrients. If you rotate your crops and plant different crops every year, it kind of keeps the soil in better condition. So there's something called IPM, which is integrated pest management. And, the idea is that we still need to produce a lot of food, and pesticides do a lot for us as do herbicides. For the pest management piece then is that, can you combine all the different techniques to keep levels of pesticides down? So basically you're going to monitor your pests at an economically tolerable level, which means that you're not going to get all your crops. You're going to lose some of your crops to pests, but at a level that's not too bad. So don't use the broad spectrum that kills all insects. Use only targeted ones. Brazil lowered their pesticide use by 90%. If you look at these graphics, they kind of show like, okay, what are you doing? You're going to monitor, you're going to use biological agents like the wasps and stuff. You're going to have some chemical controls, but you're also going to have other, it says cultural practices and preventive measures, things like the intercropping, cultivating, etc. So integrated pest management, it's actually a big topic, which we're just kind of touching on here. It's can be pretty complex and also pretty expensive. And it's actually, there's a great lot of job opportunity here because we need people who are going to be able to make sure our food supply continues into the future. So this is the picture that shows, kind of relates back to that graph where it said that China was using a lot of pesticides per hectare. If you look at United States, this is since 1990, we've been kind of staying steady. And I think we've been using more of the IPM techniques. A few final slides. What does food production, what is natural capital degradation? These are from your book. Things like biodiversity loss, those monocultures, soil degradation, water usage, air pollution. And then if these pesticides and herbicides get into our systems too, it can affect human health. What can you do, or what are some solutions? Things like organic agriculture, et cetera. And and what can you do personally? There's reducing your exposure to pesticides and also how you can be more sustainable. So I hope you've enjoyed this lecture. Make sure you let it run all the way to the end before you exit the Ed puzzle.